Okay, the question is chloropropane is a compound derived from propane by substituting Cl for H on one of the carbon atoms. First is draw the structural formulas for the two isomers of chloropropane and then suggest names for these two compounds. So we have chloropropane. So chloropropane. So we know that the mother compound is propane. So going back to our discussion, propane is the uh, the third carbon containing hydrocarbon. So our mother compound will be three carbon connected with H for each side. So we have chloropropane. So the problem is that draw the structural formulas for the two isomers of chloropropane. So meaning to say, one of the H component for this propane is changed to Cl. So meaning to say, you can change Cl here, or you can change Cl here, or you can also do that here, or you can do that here. So either way. So let's try this one. So it can be an isomer of chloropropane. Another isomer of chloropropane will be so again, we have two isomers of chloropropane. This one and this one. Sir, this would be another isomer if we change this Cl here, if you transfer the Cl in the last position. But doesn't matter since the counting of the isomer would be, the naming of the compound would be based on the attachment of the functional group, the Cl, to one of the carbons present in the propane. So if you attach this one here or here, the same thing. So wala changes, no? Kasi dire na mo siya na carbon or dire na carbon. So same isomer na siya. For this one is that ang attachment is nasa second carbon. So lahi gid siya. So this is the first isomer and then this is the second isomer. So the letter B is suggest names for these two compounds. So for this one, we have the propane, and then the chlorine attachment is attached in the first carbon. So for the functional group, you need to prioritize on the naming the location of the attachment. So this will be our first carbon, 1 chloropropane. It's because the chlorine attachment is in the first carbon. You can also name 1 chloro if you put the chlorine attachment in this side of the isomer. So the same thing. For this one, number 2, it's you have the attachment of chlorine is in the second carbon. So you name this as 2 chloropropane. So either way, if you change this position of the chlorine down here, so it's the same thing. It's the same second carbon attachment. So 2 chloropropane pa dyan. So number 2 is gallium consists of two naturally occurring isotopes with masses 68.296. 68. The first gallium is first isotope of gallium is 68.926, and the second gallium is 70.925 PMU. How many protons? First is how many protons and neutrons are in the nucleus of each isotope. So write a complete atomic symbol. So atomic symbol for each, show the atomic number and mass number. So now the average atomic mass for letter B is the average atomic mass of gallium is atomic mass average is equal to 69.72 PMU. So calculate the abundance for each isotope. So first one is we have to check the protons and neutrons and atomic symbol for both isotopes. So we all know that the location of gallium in the periodic table is in 31st. This is 31, element number 31. So to get the atomic symbol of this isotopes, gallium is you put the subscript, the atomic number of your gallium. So we have gallium 3131, and then the superscript or the upper number will be the mass number or atomic mass of each gallium. So we'll round off this number since the representation must have a whole number. So this one is 69. So and the other one is 71. So this is the representation for the two isotopes of gallium, gallium 69 and then gallium 71. So the number of protons for this one, the number of protons would be the lower part of the subscript of the element. So it contains the protons and electrons of the element. So the number of protons will be 31, and the number of neutrons is the difference of your mass and then your atomic number, that is 69 minus 31. So that is around 2 5 minus 3, so that's 22. How many per 69 minus 31 is 8. Sorry. 8 minus 38, so 60. So 38 neutrons for gallium 69. And for gallium 71, we have proton is 31 also. And then electron is 31. And for the neutron is the same process, 71 minus 31. So that is equal to 40. So that's for letter A. For letter B, you need to check the percent abundance for each isotope 69 and then 71. You are given with the atomic mass for each number. So to calculate this one, we need to create an algebraic expression to solve for the percent abundance of this one. So we'll represent gallium 69 as your x, and then since we need to have 100% abundance for both gallium, isotopes of gallium, so we'll have this one as 1 minus x. So we have the value of your average atomic mass, which is just equal to the sum of each product. So x, which represents the percent of your percent abundance of 69 gallium, and then multiplied to 68.926, which is the plus we have the atomic mass of your 71, so 70.95 times 1 minus x. So we'll get that value, so 69.72 equals, this is 68.926 x plus 70.925 minus 70.925 x. You need to transpose with the basic term for that, or you need to combine like terms. So for this one is we have eliminate this number, so we need to get the difference of that 95, and what you do here is you need to do it also here, so minus 70.925, 69.72 minus 70.95, so that is equal to 69.72 minus 70.95. You have negative 1.205. In the right side, eliminate this whole coefficient and then get the difference of this one, 926, 68.926 minus 70.925. You'll have negative 1.999x. So get the value of x by dividing negative 1.999 in both sides. So you'll eliminate this time, so you'll have the x, which is equal to 1.205 divided by 1.999. So the value of your x, which is the percent abundance of Gallium 69 is 6.6028. So meaning to say your Gallium 71 is 1 minus x. So that is equal to 0.3972. Meaning to say the percent abundance of Gallium 69 is equal to 60.28%, while your Gallium 71 is equal to 39.72%.